Yes, this is the question.
Yes, sir.
Okay. So you solve that question, I think. What is the issue in that one? If you try to solve it.
Sir, explain full answer, sir.
Okay. So you are not getting a correct answer, I think. So first of all, can I solve this one? So what we are getting at the negative terminal, what we are getting here. So this V out, because of this V out, there is a one path is created in this direction. So the voltage drop across this resistance from the V naught is the this point voltage. Okay, so if I say this is the VB, so VB is what? V naught divided by total resistance n minus 1 times R plus R. This is the current, and if the current will be passed through this resistor, so the voltage drop across this resistor is R. Okay, you can apply the voltage divided by C. Anyway, you can apply. Now R and R will be common, so I just put it as the V naught minus N upon N. Okay, if I take a R as a common from here, that is N minus 1 plus 1. This R will be cancelled out for this R, so N minus 1 plus 1 both will be cancelled out, so it is a remaining N. Now what is the VA is VI, the positive terminal voltage. Okay, and what is the equation for that one? V naught is equal to A time VA minus VB. Positive terminal voltage minus negative terminal voltage. So A time VI minus V naught by N is equal to V naught. So if I solve it, so V naught I take 1 minus
Sir,
plus, yeah,
sir, it is a ideal op amp or non-ideal, sir.
non-ideal op amp, non-ideal op amp. AS is mentioned, na?
Yes, sir.
AS, that means the basically gain will be dependent on the S. S is simply j omega.
Okay, sir.
Okay. So if gain is dependent on omega, that means this is the non-ideal op amp. And if you see the AS value, AS is A naught 1 plus S upon omega naught. Okay, so it is dependent on the frequency. So that means it is a non-ideal op amp. You can check
Okay,
the
sir.
last Tuesday class. We will discuss the op amp is the ideal when the gain is constant. If gain is variable, if gain is dependent on the frequency, that particularly op amp is not a ideal op amp. That is a non-ideal. That is a
Clear,
N
sir.
A by N. So what is V naught by Vi is A upon 1 plus A upon N. If I take A as a common, so 1 upon, so A multiply A by N plus A by N. Now take A by N as a common, so N upon N by A plus 1. Okay. Now N is given, that is a 5. So it is a 5 upon 5 by A plus 1. Now put the value of A. So it is 5 by 5 upon A is A naught 1 plus S upon omega naught square plus 1. So it is 5 upon 5 1 plus S upon omega naught square divided by A naught plus 1 If I solve it, so 5 upon, open it, so 5, 1 plus s square upon omega naught square plus 2s upon omega naught divided by a naught plus 1. That is a 5 upon 5 upon a naught plus 1. This is a constant term plus 5s square upon a naught omega naught square plus 2s upon a naught. Okay. Now you have to compare with this equation and find the value of QP. Okay, any doubt?
No, sir. Remaining part was clear. This.
And question number 6. The question number 6. 7 or 8 you are asking, or 7 or 6 you are asking? Is Mageshwara? You are asking 7 or 6?
Sir, fifth question, sir.
Fifth
5
question.
and sir. Yes, sir. Fifth question.
So in this one we have to identify the biasing. Consider the circuit below the op-amp is known in science as a finite bandwidth. The transfer function of open loop is given by that. Define the terminal of op-amp for the negative biasing. So this is my circuit. The A naught is given as a 5 by omega u bias. Okay, so we always consider where we are getting the higher potential for the negative feedback. Okay, it is mentioned in the question that for the negative biasing of the circuit, we find the terminal of op-amp for the negative biasing. So where we get the higher negative potential. So if I say this is the V naught, okay, so the voltage drop across this point is V naught minus 0.2, that is the voltage from this side to ground, upon total resistance is 70k. Okay, this is the current flowing. Now if I multiply with the resistance 50k and subtract the voltage 0.2 volts, so this voltage is the drop from this point to this point. Should I repeat the equation? Why should I repeat this equation?
Yes,
The
sir.
total current is V naught minus 0.2. Voltage is this one. Okay. The total resistance is 70k. Multiply by 50k. Why? Because this is the voltage drop across this resistance. But addition of this one, there is one more battery source, and the polarity of the battery source will be the reverse. Because when the current is flowing in that way, so this potential is positive, this is negative. Oh, sorry, it is plus 0.2, not minus, plus 0.2. Both potential will be added, so this is the overall potential at this point. Okay, fine. Any doubt?
Clear, sir.
And
Sir,
what is,
V0 is higher potential.
yeah,
V0 is higher
we
potential.
are assuming that V0 is the higher potential, na?
Okay.
Okay, so the current will be flowing in that way. If
Okay.
V0 is the lower potential, then everything will be in the negative.
Yes, sir.
Fine.
Yes, sir.
And the voltage drop across from this one, this is again same V0 to V0, so it is V0 divided by 50k times 10k. Okay, so because we have to find out the voltage at this point. So what is the voltage at this point? Is the voltage drop across this 10k. Okay, so this is the voltage drop. Now which one is higher? So for that one, I just assume V0 is 1 for the understanding. So it is a 0.8 divided by 70k into 50k plus 0.2. So it is a 40 divided by 70 plus 0.2. So it's around 0.6 plus 0.2, that is 0.8 volt. If I assume V naught is 1, so Vx voltage is 0.8 volt. Okay, and again the lower side, if I say this is the Vy, so what is Vy? This is the Vs, what is Vy? Vy is 1 divided by 10 upon 50k. Both are kk, so k cancel out, so it is a 10 by 50 or 0.2 volts. Okay, so Vx is 0.8, Vy is 0.2. Which one is the higher potential? Vx. So for the negative biasing, negative feedback, we just consider this is the negative terminal, this is the positive. Okay?
Sir, in exam we have to show this calculation.
No need to show the calculation. That is only for the understanding purpose.
Okay, sir.
Okay, now why we consider this is the negative and positive, just break the loop. Okay, apply the increased voltage, so we are having the voltage higher, that is 0.8. From this side we are getting the voltage 0.2. So if this is a positive, this is a negative, we are getting 0.8 minus 0.2, that is 0.6. That means high positive, same voltage potential. Okay, if we apply the positive voltage, then we are getting the positive voltage. And if this one is a negative and this one is a positive, so that means we are getting 0.2 minus 0.8, that is minus 0.6. That means we are getting a negative voltage. So where the phase shift will be created? In this, where the phase shift will be created in this point. So the phase shift will be created when we are considering this is the negative terminal, this is the positive. Fine?
Yes, sir. Fine.
Yes, sir.
Now someone says that me, can you please solve the mock paper in tomorrow's session? Okay. So we will take this question mock. Oh, so the subject will be descriptive image. So this is my question first for mock. It is given that R1 is equal to R2 is equal to R3 is equal to R. So for the bandwidth is equal to omega u by 4. The value, for instance, R4 should be KR. Find the transfer function and find the value. R1 is equal to R2 is equal to R3 is equal to R, and the bandwidth is omega u by 4, where AS is omega u by S. Okay, and R4 given that R4 is equal to KR. So we have to find the value of K. Okay, so the thing is that there are two nodes are available, 1, 2. So I apply, this is the VA, this is the VB. So we are getting two equations. VAI, the incoming current from coming from here, it will be go outside. Similarly, incoming current coming from here, it will be go in this direction and in this direction. So incoming current at VAI is the VI minus VA upon R1, and that will be equal to the outgoing current, so VA minus VB upon R2. R1 and R2 both are equal, so I just say VI minus VA by R is equal to VA minus VB by R. Both will be cancelled out, so I just take VI minus 2VA is equal to minus VB, or VI plus VB is equal to 2VA. Okay, now we know that according to it is a non-linear, so A times 0 minus VA is equal to V out. So V out is equal to minus A V A times. Okay, now we apply the KCL at a node B. So VA minus VB upon R2, incoming current, that will be equal to the VB minus V0 upon R3 plus VB minus 0 upon R4. Okay, so it is R, it is KR. So R and R cancel out, only remaining K. Now, if I take a LCM, so it is a K times VA minus VB plus is equal to K times VB minus V0 plus VB. Okay, so if I solve it, so K VA is equal to VB. It is 1 plus K, and this VB is also comes again K minus K time V naught. So KVA is equal to 1 plus 2K time VB minus KV naught. Equation number 3, equation number 2, and equation number 1. Okay, so I have to eliminate VB. Okay, from the equation 2, I have to eliminate VB, 2 or 3. So I calculate VB from here. So VB is 2VA minus VI. Okay, and now put the value VB here. So K time VA is equal to 1 plus 2K times 2VA minus VI minus KV naught. Okay, K time VA is equal to 1 plus 2K, 2 times 1 plus 2K time VA minus 1 plus 2K minus K, sorry, 1 plus 2K time VI minus KV. If I take this term here, so it is a no, I will take this terms here and this term here. So 1 plus 2K time Vi minus, sorry, plus K time V naught is equal to Va 2 plus 4K minus K. So it is a 2 plus 3K time V. Okay, now put the value of Va. Va is nothing but minus V naught by A. So 1 plus 2K time Vi is equal to 2 plus 3K minus V naught by A minus K. Okay, so 1 plus 2K time VIA is equal to minus 2 plus 3K upon A minus K plus K time. Okay, and V naught upon VI is 1 plus 2K, 2 plus 3K time A plus K. Okay, now A is omega U by S. So put it as omega. So minus 1 plus 2K divided by K plus 2 plus 3K omega U time S. Okay. Now my equation will be the A naught upon 1 plus S by omega N. So I have to divide with the K. So it is K, it is 1, divide with the K. Okay, so this is my DC gain. Okay, and this one is minus 1 plus 2K divided by K upon 1 plus S time S upon omega u by k upon 2 plus 3k. So that is bandwidth. Okay, omega u k upon 2 plus 3k. That is given as the omega u by 4. So omega u and omega u cancel out. So if I solve, so 4k is equal to 2 plus 3k. So k is equal to 2. Okay, so if I put the R4 is equal to 2R, we are getting the omega and bandwidth omega and omega z, that is the omega u by 4. Okay, so this is your first question. Any doubt?
No, sir.
Question second.
Sir, can you solve question number 3?
Yeah, I will solve one by one every question. No worry.
Okay, sir.
So this is the second question. It is mentioned that 1.7 green and blue. V red is 1.7, VG is 1.85, and VB is 1.95. Sorry, green is 1.8. Yeah, green is 1.85 and blue is 1.95. Okay, and the current is 2, 1.8, and 3.2. I1 is 2, I2 is 1.8, and I3 is 3.2 milliamp. Okay, so if I calculate the R red, so R red is V battery minus VR minus VR divided by I1. So that is 4.5 minus 3.4 divided by 2 milliamp. That is a 1.1 divided by 2 milliamp. So that is a 550 ohm. R blue is, sorry, yeah, R blue is V bat minus VB minus VB upon I2. That is a 4.5 minus 3.9 divided by 1.8 milliamp. So 0.6 divided by 1.8 milliamp. So it is a 330 ohm. And R green is V bat minus VG upon I3. 4.5 minus 1.5 divided by 3.2 milliamp. So 1.65 divided by 3.2 kilo. Okay, so you can calculate this one. It is mentioned second part, calculate the battery rating to operate the current for minimum 10 hours.
Sir, for resistance value, if it is point after
Yeah.
it is 333.33 in for
Yeah.
resistance value, we have to write the whole number, or 0.3 we can write.
Yeah, you can write a 333 or 333.3 because it is a subjective paper, na?
Okay, okay,
That will be considered, no issue with that.
okay, sir.
Okay, now the second part is what is the battery rating if we operate. So the total current is one is the 2 milliamp plus 1.8 milliamp plus 3.2 milliamp plus 50 milliamp.
That will be
Okay, so
say
that means
57.
total current is 57 milliamp. So if we require a battery for 10 hours, so battery rating is 57 into 10 is 570 milliampere hour. Now if we reduce the battery voltage, C, so we know the resistance value. Now I have to calculate the I1. So I1 is V battery minus 2VR divided by R red. I2 is V battery minus 2V blue divided by R blue. And I3 is V battery minus Vg divided by. Okay, this is the C part. I am not calculating the value. Okay. If the
Yes,
current
sir.
in all branches is 3 milliampere, then find the required resistance value. Now current is fixed. So R red is V bat minus 2VR divided by 3 milliamp.
Sir, here we have to consider V battery as 4.5 volt. That is
Yes,
original voltage.
4.5. But if you solve with the 4 volts also, we will consider that is the correct.
Okay, sir.
Okay, but the actually you have to calculate the 4.5.
5. Yes, sir.
V bat minus 2 VB upon 3 milliamp and R blue is V bat minus Vg upon 3 milliampere. In this case, V bat is 4.5 volt. Okay, so this is the second question. Now move to third question. For a given second order filter, calculate the full frequency when R1 and R2 is equal to R and C1 and C2. It is mentioned that R1 is equal to R2 is equal to R, C1 is equal to C2 is equal to C, R3 is equal to R. Okay. Any other things? Second order filter for effective calculate the pole frequencies. Now, how we calculate the pole frequencies? So first of all, we calculate the transfer function. Okay, the input signal is applied on the positive terminal. That will it is a non-inverting amplifier. Second thing, the feedback. If you see the feedback, so increase the voltage, change it. So here it will be increases. Now because of negative sign, it will be decreases. Okay, increase the voltage if this is the DC voltage, so it will not pass through the capacitor. Okay, so that means we have a negative feedback. So we confirm two things. One is the feedback is negative, and second the non-inverting amplifier. Now, what we can do, we just take the voltages here. This is the Vy, this is the Vx. Okay, what is the gain? A is 1 plus R3 by R4. Okay, because non-inverting amplifier, so gain is 1 plus R3 by R4. So
Yes,
that
sir.
is 1 plus 4 are equal, so 1 plus 1 is 2. So gain is 2. Now apply the KCL. We have a two node Vx and Vy, that means we require two equations to eliminate these two unknown variables and finally find the transfer function in terms of V0 and Vi. Does anyone try it? Anyone?
Sir, at Vy 3 node, that will be 3
Vy
equation.
as a three node, okay.
One incoming and 2 outgoing. If we consider from V in to Vy.
Like for example, I am just taking that this is my incoming current. It will be go in this direction and in this direction. Now
Yes,
from the
sir.
Vx, one is the incoming current, it will be go in this direction. Here the current is 0. In this direction, I is 0.
Yes, sir.
Because ideal operation amplifier, if A is not given in the question, that means the A is not dependent on the frequency.
Yes, sir.
So in the ideal op amp, we consider the current incoming inside the operation amplifier is 0. Now write the KCL. Apply the KCL. V in
V minus V
Vy
by
upon
R1.
R1 is equal to Vy minus V out divided by 1 by C1s
Yes,
plus
sir.
Vy minus Vx divided by R2. This is my one equation. Second equation is Vy minus Vx divided by R2 is equal to Vx divided by 1 by C2s.
C2.
Okay. And if you find the Vx, so Vx from this point and this point will be same. So this is also Vx. So Vx is what? V out upon R3 plus R4. This is the current flowing in this direction.
Into R4.
Multiply the R4. So that is the V out by 2. This is the third equation. First, second, and third. Eliminate Vx and Vy. So your complete equation will be in the terms of V out and V in. Find the transfer function. Now from the equation 2, you have Vy by R2 is equal to Vx 1 over R2 plus C2S. If I take the LCM, so
Sir,
Vy
we can write all as R and all as C.
C2S. Yeah, I can write that one. So
Okay,
this
sir.
is my equation number 2a. I just write as a 2a. So Vy is equal to Vx 1 plus RCS. Okay. Now Vx is V out by 2, so I put a V out by 2. So my V out is Vy is in the terms of V out, Vx in the terms of V out. Now I apply the equation number 1. So V in by R is equal to, I just take Vi here, so Vy by R plus Vy by Cs, Vi multiplied by Cs this term, plus V by R this term. Okay, minus Vx by R this term, and minus V out time 6. Take a R LCM, so V in is equal to Vy plus Vy RCS plus Vy minus Vx minus V out times RCS. Now put the value of Vy and Vx. So Vx is V out by 2. So this is the minus V out by 2 minus V out times RCS. And I take a Vy as a common. So 1, 2 plus RCS. Now put a Vy by 2 here, Vy here. So it is a V out by 2, 1 plus RCS, 2 plus RCS minus V out by 2 minus V out by multiplied by RCS. That is equal to V in. So V in is equal to, now take a V out as a common. It is a 1 plus RCS, 2 plus RCS divided by 2 minus 1 by 2 minus RCS. So V in is equal to V out. If I multiply, so it is a 2 plus 2 and 1, 3 RCS plus RCS whole square divided by 2 minus 1 by 2 minus RCS. So V in is equal to V out 1 plus 3 by 2 RCS plus 1 by 2 RCS square minus 1 by 2 minus RCS. So 1 by 2 and 1 by 2, this is a 1 by 2. 3 by 2 minus 1 is, this is also 1 by 2. Okay, both will be cancel out. So it is V out by 2, 1 plus RCS plus RCS square. So V out by V in is 2 upon 1 plus RCS plus RCS square. Okay. So if I open it, it is 2 upon 1 plus S upon 1 by RC plus S square upon 1 by RC square. Now what is omega P? If I compare it with that one, so it is a 2 upon 1 plus S upon omega P QP plus S square upon omega P square. Okay, so this is the omega P square is 1 by RC square. That means omega P is equal to 1 by RC. And second is the omega P QP is 1 upon RC. This implies QP is 1 upon RC into omega P. Omega P, if I put the value, so QP is equal to 1.
Sir,
Yeah,
for pole frequency, we have to find omega p.
yeah,
When I have to find FC, that is cutoff frequency.
yeah. That's the cutoff. C is the for the cutoff frequency and P is the pole frequency.
Okay, sir. Now I have one question here.
Yeah,
This is Salenki second order low pass filter.
yeah.
Then we have in lecture we have get direct equation. Can
Yeah,
we
the
put
direct equation is basically because they have explained everything to you. But in the exam, you can't directly write the equation, no?
okay, but this equation is same as in the lecture,
Yeah.
and I did this with the exam with the equation.
Hmm.
Uh, I got the same answer as you get here.
Hmm.
Then can we use that or
You have to
because
solve that, no? You have to
here
solve that.
because you have to I have to solve, no sir?
Yeah, you can't take directly the transfer function. If you take the
Okay,
transfer function and if the question is 10 marks, so
okay,
directly from the transfer function you will get the QP is that.
okay, sir. Okay,
Okay.
okay, sir.
Like for example, I am giving the value of R1 and R2 is equal, C1 and C2 is equal. If both are not equal, then what?
Yes, sir.
In the omega P, it is fine that your omega P will be now if the C1, C2 and R1, R2 both are not equal, the omega P is 1 over root of R1, R2, C1, C2.
C1, C2.
But if
Yes,
I
sir.
am asked the QP, so QP you have to write the equation, completely solve that. Then you know what we are getting in the QP.
Okay,
Okay.
okay.
Now the question number 4. Can you find out the same? Question number 4. If we are getting Vx, so what is my V out? It is inverting a non-inverting amplifier. So 1 plus n square minus 1 times r upon r times Vx. So r and r cancel out, 1 and 1 cancel out. So V out is nothing but n square Vx. Now we have to find the Vx. Okay, so first of all, we identify the terminals. Okay, if you break this loop, apply the positive signal. So here you are getting positive, but it won't work on the DC. So your capacitor will behave as an open circuit. Okay, so we consider this terminal should be negative, this should be the positive. Okay, now if this one will be the negative, so your this point is, if I say this is the VA, so VA is Vx by 2.
Yes, sir.
Vx into the current is 9 plus 9 multiplied by the 9. Okay, so that is simply Vx by 2. This is Va. Okay, now for the positive terminal, we are considering this is the VB, this is the VC. Now apply the same mechanism that we do already solve and find initially the Vx. Now after putting the Vx value in the first equation, you will get V out. This is your equation 1, this is your equation 2. Now with
Sir,
respect to
can
this,
we write VC as VA?
yeah,
Can we write VC as VA?
any you can choose anyone. And this
VC
is
equal to VA, na, sir?
VC is equal to VA. Yeah.
Yes, sir. I did like this, but somewhere I did mistake in the
Okay.
calculation. So I didn't get answer like exactly. I think I
So
did
can I solve
calculation.
it, or you will try it again?
Sir, I will try it again.
Okay, okay, okay.
In sir, first question number 1 in
Ah,
mock test, please show the picture there.
okay. So the more question number 1. Yeah.
Yes, sir. In another question in PYQ, R3 is grounded, and there is another resistance with uh, R4.
In which one?
PYQ, I think it is 2025 August.
Okay, last year. So I think the question will be uh, previous year quiz 2. VI
आधार कार्ड लगे
2 or 3 or 4 or 5.
Sir, R4 is connected with good.
V out. This one?
Yes, sir. Please
Okay.
give the idea, then I will calculate.
Okay. So I
Calculate.
just assume this is a VA. This point is VB. So apply the KCL. So the current is coming, it will be going out. So VI minus VA by R1 is equal to VA minus VB divided by R2. This is the one equation. For the
Yes, sir.
second equation, VA minus VB divided by R2 is equal to VB. One current going this side, one current going this side. So VB by R3 plus VB minus V0 divided by R4. Okay, this is
Yes,
the
sir.
second equation. And last one we are getting
Sir, VA equal to 0.
VA is equal to A times, wait a minute, A times 0 minus VA. So VO is equal to minus A times VA. How VA is equal to 0?
Sir, I considered ideal case.
Why? I think it is given that AS is equal to 1000 upon S.
Yes, yes.
Okay,
Non-ideal.
sir. Okay, sir, non-ideal.
So if it is A is the 1000 upon S, that means it is dependent on frequency. So non-ideal op amp. And if ideal op amp is non-ideal, we can't apply the virtual ground concept. Okay, virtual ground concept is only applicable for the ideal for the solving purpose.
Okay, sir, clear, sir.
Understood?
Clear, sir.
Yeah. Now we got three different equations. Can you solve it and find the terms in VI and V out? So you eliminate VA and VB.
Yes, sir, I can. But
Okay.
what about, sir, R5?
R5 is simply load resistance. Either
Okay.
I connect it here or either I connect it here. That is the R5.
Sir, it is given that if R1, R2 equal to R, R3, R4 equal to 2R,
Uh,
and R5 equal to 4R, then
okay.
derive the expression of transfer function.
Yeah, I can either assume the R5 is a 4R or I can assume R5 is a 100R. So this is the load resistance. And load resistance, we already discussed that load resistance never create a effect on the transfer function.
Yes, 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 sir.
Okay, that is R5 is only for confusing.
Okay. Now I got it. Yes, sir.
Part B and C, you calculate the value of R5, so we consider the bandwidth will be same. Okay, so R5 doesn't create any effect on that. No need to
Again, sir,
solve
in
for
question
R5.
number C, given let the R5 equal to 2R, then calculate the bandwidth ratio of both
No issue
circuits.
with that one. What is the bandwidth you are getting from the first circuit? What you are getting bandwidth from the second circuit?
Second circuit. Yes,
Calculate
sir.
the ratio, bandwidth ratio.
Okay.
R5 doesn't create any effect, na?
Yes, sir.
Okay, that is only for the confusions.
Okay, sir.
Okay, R5 is basically load resistance. Load resistance never create any effect on the transfer function.
Yes, sir.
The transfer function is same, that means bandwidth is also same. Okay,
Yes, sir. Sir, can you explain the Roche filter circuit?
Rouse filter circuit. Rouse filter is just wait a minute. Route is I think this one. This one, Gauss filter.
There was another capacitor, yes, capacitor resistance.
What is Gauss filter?
No.
I think this is the circuit, na?
No, in the lecture, the circuit is different. That is, with negative terminal, there is two resistance and two capacitors, R1, R2, and with VY, that is another resistance, that is R1, same resistance.
Which lecture can you tell me? Just check the
Lecture
circuit.
5.
Lecture 5 of
Lecture
title.
5 of week 6.
Just wait a minute. I just check the circuit with circuit errors. Do you have the lecture name also?
Sir, it is a second order low pass filter.
Okay.
Second order low pass filter, part 1.
Part one.
That is lecture 5.
Part 1, no circuit.
Sir, two op amps are reduced using a passive RC filter to find Vx.
Mhm. Okay. Uh,
Sir, it is band pass in band pass filter. After band pass filter,
this circuit, I think, 3 particularly.
one op amp.
Second order band pass filter.
Yeah.
If you have a circuit, can you show me? So I think you will get the. I will get the better idea.
Sir,
If you
you draw. I am telling you to. I am
okay,
helping.
yeah. So we have a one op amp. Okay, fine.
Upper is negative terminal, lower is positive terminal. It is grounded. Positive is grounded. And with negative terminal, there is two resistance series in series, R1, R2. And from middle of R1, R2, there is a capacitor grounded. That is
Okay.
C1.
See that.
And input is Vi. And from upper, this R2 is connected to negative terminal. Yes, there is a capacitor with V out. Yes, sir. Another resistance, that is between from R1 and R2, it will go to V out. Yes. Yes, sir. This is the circuit.
Okay.
And the upper resistance value is also R1.
Yeah, fine. Okay, okay, okay. This is the C2. Yes, so what we do again, we apply the KCL in that scenario.
Please try to you
So
find
this is the
transfer
VA,
function.
this is the VB. Okay, so the current, it will be passing from here, it will be go in this direction, in this direction, and in this direction. So VI minus VA upon R1 is equal to VA minus V out upon R1 plus VA minus VB upon R2 plus VA by 1 by C1s. Okay,
Yes, sir.
and the current that is coming, it will be passed through this one. So this is my first equation. The second equation is VA minus VB upon R2, that is equal to VB minus V out upon 1 by C2s. This is my second equation.
Yes.
Okay, so we eliminate. Now VB is equal to 0
Yes, sir.
because ideal of a virtual ground concept, so VB is equal to 0. So VA upon R2 is equal to minus V naught by 1 by C2s. So I just calculate VA is equal to minus V naught times R2 C2s. Okay, this is my third. Now VB is 0, so I put it 0. So VI by R1 is equal to VA by R1 plus VA by R1 plus VA by R2 plus VA by multiply by C1s. So VA have a 4 terms, VA, and VA minus V naught by R1. Okay, so VI by R1 is equal to VA. I take the LCM R1 R2, so it is a VA time R2 plus VA time R2 plus VA time R1 plus VA time R1 R2 C1s. Or VI, just take a common, so it is R2, it is R2, R2 and R2 becomes 2R2. So 2 plus R1, 2R2 plus R1 plus R1 R2 C1s minus VA naught by R1. So R1, R1 and R1 cancel out. Now put the value of VA. So VI is equal to minus V naught R2 C2s 2R2 plus R1 plus R1 R2 C1s divided by R2 minus V naught. R2 and R2 cancel out. My VI is equal to minus V naught. I take a common. That is a 1 plus R2C2S plus, sorry, 2R2C2S plus R1C2S plus R1R2C1C2S square. So V naught upon Vi is equal to minus 1 over 1 plus R1C2S plus 2 times R2C2S plus R1R2C1C2S square. So it is minus 1 over 1 plus S, I take a common, R1C2 plus 2 times R2C2 plus R1R2C1C2 S square. Okay.
Yes, sir. Okay.
Any other question?
Sir,
Yes, sir. In 2025 PYQ, first question, that is 3 upon question,
Hmm.
August 2025.
Okay. So I think some sort of this type of question. Huh?
No, sir. Circuit is different.
Hmm. Circuit is different.
Yes, sir. V out is here in first op amp over
Okay.
resistance, and first op amp does not contain capacitor.
First op amp doesn't contain capacitor.
Yes, sir.
Let me check.
Please see the question. And third op amp output is Y. Middle op amp output is X. Yes, sir. This is the circuit.
The same mechanism, apply the KCL for that one.
Please help me to do that.
Okay. Just tell me where you are getting some issue.
Yes, sir. In equation.
First of all, check this is the negative feedback. This is the negative feedback, and this one is the negative feedback. That means all particularly will be the negative feedback. So complete, if I'll take this loop, so this is also negative. So if I apply the signal here positive, it will be the negative. It will be positive here, again it will be the negative. So signal will be coming here again at a negative. So that means all loops will be in the negative. Clear?
Okay. Yes, sir. Clear.
First this loop negative, second this loop negative, third this loop negative, and fourth whole complete loop will be also in negative. This one is also in negative.
Okay.
Okay, so we confirm first thing is that. Now after that, what we can do?
We have to find that Vy, Vx, that.
Yes.
Then Vx, V out, that from, yeah, the input
We have to
output
find out,
ratio.
I think, V out by V in,
Yeah.
and then what we have to find out, wait a minute, we have to find Vy by V in, V out by V in.
Sir, from where we start?
Always start from the left side.
Okay.
Always start from the left side. So, okay, let's take a point. We consider the different points, okay? So, if I consider here, it is a point, B point. Now, what is the voltage drop across this point? We have another path. So the voltage VB is what? If we assume that the voltage at X is greater than V in, because this is the output of op-amp, and output of op-amp always having the amplification. So Vx
Yes,
is greater than V in. So what is the voltage drop across VB?
that is R4 by R4 plus R5 into Vx.
Vx minus V in upon R4 plus R5 times R4 plus V.
Okay. Yes, sir.
Why? Because the current, if it is a grounded, so what we assume Vx minus 0 upon R4 plus R5. But here V in is also there, na?
Yes, 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 yes.
The current value is Vx minus V in divided by R4 plus R5. This is the current. The drop across this one is multiplied by R4.
Yes,
And there is also a voltage like we consider in this form. Okay. So the current is flowing from Vx to V in. So this is the positive, this is the negative. So this V in voltage is also added across with this voltage.
yes, sir.
Okay, so this is the voltage drop across VR4 and total V in is VB. Because both voltage will be connected between VB and ground. So that means that overall voltage addition will be at this point VB. Okay.
Yes, sir.
Now if VB is this one, that means VA is also this one.
Yes, yes.
Now what is VA? The second equation of VA is now if you check at
That
VA,
will
V
be,
out effect is also there.
yes, and that will be Vy also.
VY is also there.
Yes, sir.
So can you apply that? If you see the inside circuit, the op-amp 2 and op-amp 3, that is only the inverting integrator.
Yes, sir.
Okay. So if you see, this is the V out voltage, this point is the V out. So V out by Vx is what? Vx by V out is what? If this point is the V out, so that means this point is also V out.
That is minus 1 by S R1 C1.
So Vx by V out is minus 1 by R1 C1s. And what
Yes.
is Vy by Vx?
That will be minus 1 by R2 C2S.
R2 C2s. So what is Vy by V out? What we have to calculate? We have to calculate sorry, V out by V in and Vy by V in. Okay. So what is V out? Vy by V out? So if I
That-
calculate the Vy by V out, so Vy by Vx into Vx by V out, Vx and Vx calculate. So this is the Vy by V out. Okay, so
Yes.
the value is minus 1 by R1 C1s into minus 1 by R2 C2s. So you are getting 1 by R1 R2 C1 C2s square. That is V by V out. Okay, now if you have to calculate the Vy by V in, so what is the V out by V in? You calculate the voltage at VA terminal, okay, and put VA is equal to VB. So you will get the equation of V out by V in. Okay.
Sir, Vy by V out.
Hmm.
Uh, is it 1 by R1 R2 C1 C2 square?
Yes. This is the VY, this is the V out. So basically both integrator multiply.
Yes, sir. Yes, yes, yes,
So
yes.
it is a 1 by R1 R2 C1 C2 S square.
Yes, sir.
Now write the KCL for VA. Okay. And just equate VA is equal to VB. So in this equation, if you calculate the KCL for VA, so you have a V out is also there, VY is also there. Now eliminate VY in terms of V out. You got the equation. Okay,
Okay.
so eliminate Vy in terms of V out. So only the V out term is there in VA. Similarly, in the term of VB, this is your VB. In the VB, Vx is there. Now can you write a Vx in term of V out from this
Yes,
one?
sir. Yes, sir.
Okay, so only this term is in the term of V in and V out.
Yes, sir.
Okay, and VB is also V in and V out. Now equate these two terms and calculate the V in by V out by V in.
Okay.
Okay,
Okay. Okay. Okay, sir.
anything else?
No, sir. I have no doubt now.
Mageshwaran.
Yes, sir.
Any doubt?
Sir, explain Sallen-Key filter, sir.
Explain Sallen-Key filter.
Yes, sir. Week 6, lecture 6, sir.
Week 6, lecture 6. Can you tell me the title? I just check the circuit.
Second order filter part 3, sir.
Second order filter part 3. Okay, just give me a minute. I just check the circuit. Okay. Uh, R1, R2, C1, C2. R1, R2, C1, C2. Yeah, this one.
Yes, sir.
I assume this is the VA, this is the VB. So what is the V out is K time VB. The voltage we are getting multiply with K, we are getting the V out. Okay.
Okay, sir.
Now can you apply the KCL on VA point and VB point? The current it will be going this direction, it will be going this direction. The current is coming here, it will be going this direction. So VI minus VA by R1 is equal to VA minus V naught divided by 1 by C1S plus VA minus VB divided by R2. So V1 upon R1 is equal to VA 1 by R1 plus 1 by R2 plus C1S minus V naught divided by 1 C1S minus VB divided by R2. Okay. Now what is VB? VB is K time V naught. Sorry, V naught is equal to K time VB. So VB is V naught by K. So I put it here V naught divided by K R2. So it is V1 by R1 is equal to VA 1 plus R1 plus 1 upon R2 plus C1S minus V naught 1 plus C1S plus 1 upon K R2. That is minus V naught K R2 common, so 1 plus K R2 C1S, or I can break it to V2 1 by CS K R2. Okay.
Okay, sir.
Now apply the KCL at VP point. Apply the KCL on VP point. So we are getting VA minus VB upon R2 is equal to VB upon 1 by C2S. Now from the equation 1 and equation 2 you can solve, eliminate VA and VB. So your complete equations. So this is your one equation, equation number 2. Okay, and your equation number 3 is this one. Now with the help of these three equations, eliminate VA and VB. So you will get the output equation in terms of V out upon VI. Okay. Second thing, if you see that this particularly will be create a RC combination. Okay, so if you remember, so this is the R, this is the C, R and C. If we apply the VI, what is V out? Yes, what is V out?
VI divided by 1 plus RC.
VI divided by
1 plus RCS.
RCS. So V out is equal to VI upon 1 plus RCS. So V naught upon VI is 1 upon 1 plus RCS. Okay. So if I say this point and this point is both same, so the voltage at this point is, if it is V naught, so the V naught equation will be same. So can I write as a VA is equal to VI times 1 plus RCS R1C1S? Can I write it?
Yes, sir, you can.
Okay. Now similarly, if this is the input
Sir, but the
voltage
capacitor is connected to V out, sir.
V out. Okay. So that is one thing we can take. This is the second effect. Okay. Because of this VI, I just consider what is the voltage at this point. Because of this one, we have some other voltage. Okay. Let's take one thing. One more thing is that now for assume that if this is the VA, if I assume this is the VA, that is the effect of this voltage and this voltage. Okay. Can I write a VB as a VA upon 1 plus R2C2S? Yes or no?
Yes,
Yes,
yes.
sir. Yes, sir.
We can write that one. VA is something that is the combination of VA plus VE naught. Okay, but this is the overall voltage is VA. Now VA we are getting according to this one, we are, this is the RC circuit and VB will be this point. And we know that VB multiplied by K is simply V naught. So we are getting VB is equal to V naught by K. So I just put both equation. So that is the only solving method. So V naught by K, because it is also VB, and that is VA upon 1 plus R2C2S. So that is the, if you consider, this is the fourth equation between the relation between V naught and VA. So out of these four equations, you can solve it, eliminate VA and VB. Finally, your equation will be in terms of VI and V. Okay.
Okay, sir.
Sir,
Yeah.
do you have December 24 question with you? Quiz 2?
December 24. Wait a minute.
Sir, how many questions for this too, sir?
We have, I think, three questions we have. Three questions we have.
In quiz 2?
Yes.
Okay, that each contains 10 marks then.
10 marks.
Okay.
Yeah. In quiz 2. Which question?
Sir, that is two-stage forward amplifier.
Okay.
Given GM1, GM2, R1,
Uh,
R2.
that is a simple question from the, I think, from the
Yes,
video lectures.
yes, sir. We have to put the value in direct in the equation.
Yeah, you can directly, you can solve that one. First of all, you can solve that to derive the transfer function. Hai na?
Okay.
It is question, if you see the statement, so it is a derive the transfer function V naught upon Vi and the loop gain. You have to derive these two functions. Now after that, you put the values of GM, R1, R2, C1, C2. Then find the quality factor.
Okay.
Okay, so you can't write directly the equation.
Okay. 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 Okay, sir.
Okay. Any other point? Any other point? If no doubt, we can stop here.
Yes, sir. Question will hard or medium? Can we answer tomorrow?
Better, it is little bit as compared to quiz one. Quiz
Okay.
one is very easy.
Yes, sir.
Okay, I have not prepared that one. If you see the previous year quiz paper, so that is typical. But this time the quiz one is easy.
Okay.
Quiz two, if you solve the, if you basically read out all the content, you can easily solve. The thing is that point is that you just do the mistake in KCL, KVL, and data. So just be clear with that. Recheck, basically cross check your calculation.
Yes, sir. Because this week there is lot of calculation
Yeah,
and very much it is possible in error in calculation.
yes, exactly. So just recheck your calculations.
Okay, sir.
Otherwise, you can solve easily. If you are go with the weak content, all weak content. If you complete your assignment by your own, you will completely solve it.
Okay,
You
sir.
will get the 30 marks.
Okay,
Okay,
sir.
if you solve by own. If you are taking help and if you are taking just only cheat, that is your choice. If you complete your assignment week 5 to week 8 by your own, you can easily solve.
I have tried in my own.
Yeah, yeah.
See, I made some mistakes in every time in calculation, long calculation in
So just
my.
that's why I just tell you recheck your calculation after doing that.
Okay, sir. Okay. Thank you, sir. Thank you.
Yeah. Okay. So thank you all and good luck for your exam.
Thank you.
Thank you, sir.